Thank you very much for taking the time to watch this panel. We are a Japanese research group exploring diverse artistic expressions on the theme of life and matter. The videos you saw at the start of this presentation are two artworks, Mary Had a Little Lamb by Kazuhiro Jo and Paul Demarinis, and Chromaphony by Juppo Yokokawa. It may have sounded like noise at this point. However, we will return to these works later. This panel will discuss three historical and contemporary examples of phonography as a sound-writing technique. By examining each case from a historical and artistic perspective, we claim that the concepts of transduction and attunement have theoretical validity in demonstrating the dimensions of non-human aesthetics in media art. The three case studies begin with a reconsideration of the historical practice surrounding Edison's development of the phonograph, followed by the introduction of two media artworks that attempt to reinvent it in the present day. The first, a study by Yasuharu Akiyoshi, argued that the development of phonography in the 19th century was a consequence of the material intervention of Edison's own body. Next, using a relevant contemporary work, Mary Had a Little Lamb by Jo and Demarinis, Jo himself will demonstrate how the reinvention of sound technology, with its simple electromagnetic action and DIY digital fabrication technology, embodies the action of mechanical transduction and physical attunement. Finally, Yokokawa introduced chromaphony, a unique audiovisual expression realized from the biological tissue of the squid. This biomedia artwork is an attempt to alter the electric current as a sine wave that causes the squid's body color to change, and to attune the conventional acoustic technology to the bodies of non-human animals. And the keywords that run through these diverse cases are the concepts of transduction and attunement. While transduction was originally an engineering concept with roots in acoustics, it has recently gained popularity in the realm of media theory and sound studies. In particular, according to Stefan Helmreich, transduction is a process by which sound changes as it traverses the media, as it undergoes the transformations in its energetic substrate. This knowledge provides a perspective that perceives sound effects across multiple media, for example, from electrical to mechanical substrate, as transformations of material energy. Interestingly, his discussion of science anthropology reveals this concept from the ethnography aboard a deep-sea exploration submarine. In the deep sea, where human audiovisual perception is not applicable, the senses necessary for exploration are already augmented by sonar, hydrophones, and other machineries. Helmreich thus explains that the assemblage of the sub and its encapsulated scientist is clearly a cyborg, a combination of the organic and mechanic, in which transduction occurs. However, such transduction does occur not only in liminal environments such as deep-sea sub, but rather in our bodies, which are usually embedded in media environments without being aware of it. The reason we are not aware of this may be because we have lost the opportunity to experience the body as a transducer and the assemblage in which it is embedded in the contemporary media ecosystem. If this is the case, then one of the potential purposes of media artworks is to reveal such sensory effects in a new light. It is then necessary to attract the physical engineering concept of transduction to actual sensation and perception. For this purpose, we propose the concept of attunement developed by the Belgian philosopher Vincent Depre. She closely observes encounters between multi-species in various scientific experiments, and studies how beings are engendered in actual encounters and consequently mutually enable new meanings and identities in their empathy or communication. For example, a talented rider does not have power over a horse to ride it, nor is the horse tamed by the rider. Both the horse and the rider sense each other and become a part of each other. Therefore, human bodies have been transformed by and into a horse's body. Consequently, a rider and a horse can gallop together. Something comparable is found by Depret in the procedures of scientific experiments. The embodied communication is established between humans and non-human beings, including horses and rats and birds, etc., through their senses and affect. With this kind of communication, humans can act as observers and animals to be observed. She thus theorized a method for thinking with non-humans and transforming with them through the concept of attunement. However, does attunement occur only between humans and non-human beings whose brains and nerves have developed to the point where embodied communication is possible? On the contrary, we propose that attunement may occur between humans and non-intelligent organisms, and in fact, even between humans and technology. Therefore, how can we describe such attunement, and what is its relationships to the transduction described above? We'd like to consider these questions in the following three cases.
In this presentation, I will discuss the transduction and attunement in the case of Thomas Alva Edison, who invented the phonograph in 1877. First, I will overview the history of modern sound technology. Over the course of the 19th century, phonography was reinvented repeatedly. Originally, the term phonography meant sound writing technique and referred to a system of phonetic shorthand writing. Leon Scott, a French engineer, reinvented handwriting phonography in 1857 as a phonautograph. It was reinvented by an American inventor, Alexander Graham Bell, into the telephone in 1876. The following year, Edison reinvented it into the phonograph, the name of which became to represent modern phonography. Moreover, as we will demonstrate further, this has been reinvented in media art. It is important to understand its cultural origins in the 19th century to evaluate its aesthetic value. According to Jonathan Stone, sound reproduction technologies can be defined as transducers. Both telephone and phonograph are examples of transducers. They transform sound waves into other things, such as electric waves and grooves, and back them into sound again. This principle was achieved by using a thin membrane called the diaphragm. The diaphragm resonates and trembles in response to sound waves. This enables the transmission of weak sonic energies to mechanical parts. Furthermore, this mechanism was based on the human middle ear. Modern physiologists have redefined the human ear in two distinct ways. Initially, the ear was regarded as an independent organ separated from others. Further, each part of the ear was regarded as a medium or a machine. For example, Hermann von Helmholtz, German physiologist, compared the human ear with various devices. Modern inventors have applied these concepts to technology. The phonograph designed by Leon Scott was the first device to employ a diaphragm similar to an eardrum as a transducer for recording sound. It was Graham Bell who explicitly regarded the ear as a device. Moreover, he developed an ear phonograph using a real human middle ear. Its construction inspired him to use a diaphragm for converting sound into electric signal. Following this, Edison used the same diaphragm to record and reproduce sound. In other words, inventors associated the human ear with the machine to reinvent phonography. However, this was not the case with all inventors. The phonograph, particularly for Edison, was not merely an extension of his own ear. Edison lost his hearing as a child. As a result, he lived the majority of his life as a deaf man. His eardrum was perforated due to a chronic infection in his middle ear. Thus, his eardrum did not function well as a transducer or a medium of sound. So, how did he test the sound of his inventions? One method was touching the device with his finger. In 1877, Edison connected the wire to the diaphragm of the telephone and touched it. Using his finger, he was able to feel the tremor of the speaker in order to determine the sound quality and volume. According to him, the phonograph was allegedly inspired by such a tactile sense of hearing. He also claimed that biting by teeth was another useful method. Upon biting into the sound source, the vibrations were transmitted from the teeth to the skull and finally to the auditory nerves. As a result, he was able to hear the sound without eardrums. In 1877, Edison wrote that he tested the sound of the telephone by biting into a relay. He also left a phonograph with teeth marks among his belongings. Hearing by means of head was another similar method. During his last years, Edison often attached his forehead to the phonograph. This enabled him to hear through the bone conduction. Stephen Conner describes these techniques as rewiring the body's circuitry, as Edison short-circuited his mouth and ears by biting his phonograph. Nevertheless, there is a point that should be added to this suggestion. The phonograph itself was transformed into part of Edison's body, and vice versa. In the physical attunement, Edison's own body and the machine acted together as a novel transducer, forming a human and non-human assemblage. Edison's case provides an opportunity to rethink the relationship between humans and machines. There are 3 points to consider. First, sound reproduction technology of modern phonography can be considered as transducers. Second, it was modeled on the human itself as a transducer. Third, these two transducers transform with each other through physical attunement. As we have seen, when Edison bit into the phonograph, he and the machine acted as a transducer that was both biological and mechanical, indicating a human and non-human assemblage. Such assemblages can also be found in media art. We will discuss these possibilities in the following two case studies.
Next, we will re-examine the transduction and attunement in the following work, Mary Had a Little Lamb, 2019. In this work, we found 4 transductions accommodated by 2 artificial attunements. Through the talk, I will explain the principles and schematic of the work as well as the transductions and the attunements. Mary Had a Little Lamb is a work by myself and Paul Demarinis. Though our history, people invent printing technologies in diverse ways. For example, this is a figure of prints with woodblock from 8th century in Japan. In Europe, Gutenberg and others invent letterpress printing in 15th century. In 1903, the first commercial offset printing system is developed. In 1969, Gary Starkweather invented the idea of laser printer at the Xerox Webster Research Center. In 1981, the first laser printer for office use, the Xerox Star 8010, is in the market, and in 1984 Adobe Systems produced PostScript in market. With the all printing technologies, the basic principle is a kind of same, to put inks on a paper. To realize, Mary Had a Little Lamb, we combined this basic principle of printing technology with a simple physical phenomenon, electromagnetic induction. As Lenz depicted in his law in 1834, when a magnet moves around a coil, changes in the magnetic field induce an electric current in the wire of the coil. We actuated the strongest type of permanent magnet, neodymium, with calculated gaps of the PostScript print with a laser printer. With the principles and schematic, we found 4 transductions accommodated by 2 artificial attunements. At the rest of the talk, I will step by step explain the transductions and attunements. At first, we transduced a waveform of PCM audio data into a series of black and white stripes with the help of BTC Sound Encoder and Adobe Illustrator on a computer. Next, we printed the stripes in a circular shape using a PostScript laser printer. The magnet was placed on the stripe on a turntable. We attuned the position of the magnet so that it was as close as possible to the coil, but without touching it. As third transduction, the coil picked up the change in the magnetic field by the vertical vibration of the magnet. We amplified the electricity from the coil and produced sounds from the speaker as fourth transduction. As the sound source of the work, we selected a voice as a particular case of sound. The well-known phrase of the Edison, "Mary had a little lamb," with one of the newest voices of WaveNet, a deep neural network for generating raw audio waveforms. The voice you are hearing now was also uttered by the WaveNet. Let's listen to the piece again. This result might have been perceived as a collection of collisions and friction. However, once you hear the sentence, "Mary had a little lamb," you cannot avoid making out the voice. It is similar to apophenia, where one perceives a familiar pattern in random noise. However, it is not. This phenomenon recalls an early idea about the phonograph that Edison expressed to his friend, Alfred Mayer. In his letter, Edison described a phenomenon that is impossible to escape once one becomes aware of sound from a machine. Here is a quote.
"Another phenomenon I have noticed is that if two simple but different sentences are put on the machine, and a person who had never heard of such an apparatus be brought in and told to listen, he will not even after a dozen repetitions be able to say what it is. But if the first sentence is told him and then reproduced, he generally says, 'Why, that's perfect.' The second sentence is now reproduced when he generally reads it or part of it the first time and the whole the second time if simple. The same thing has been noticed of the telephone, and I think it lack of confidence, or some obscure effect of the mind upon the hearing apparatus. They do not expect or imagine that a machine can talk, hence cannot understand words.
Once I attune my hearing, the collection of collisions and frictions will be the matureness of the voice. Thank you for your attention.
Hello, I'm Juppo Yokokawa. In this presentation, I describe chromatophony as a third example of reinventing phonography. Chromatophony is a series of performances by myself. In this performance, the computer-generated sound is transduced into images with the squid's body surface. First, I would like to show you a 2-minute video clip of this performance. Usually, sound data is converted into electrical signals, and it becomes sound waves by vibrating the speaker cones. In this performance, the sound data converted into electrical signals actuates the pigment cells of the squid. In this perspective, I recognize the surface of the squid's body as a phonography. The rapid color change in squids is made possible by a set of organelles called chromatophores, comprising multiple muscles and nerve cells, and pigment-containing pouches. Each chromatophore contains only one type of pigment. During color changes, only the pouches contract or expands, changing them in size. Using this phenomenon, Backyard Brains, a company that sells educational neuroscience laboratory kits, conducted an experiment wherein music was used as the electrical stimulation to manipulate a squid's chromatophores. In contrast, we created a series of signals tailored to the characteristics of the chromatophores and made them audible to people through speakers to achieve audiovisual unity when observed. Like the human audible range, there is an upper limit to the frequency of electrical stimulation that can move chromatophores. To find the appropriate frequency, we increased the frequency of 1 second of sine wave in steps from 0 Hz to 1000 Hz, and investigated which frequencies were most likely to stimulate the pigment cells. As a result, we found that frequencies around 90 Hz were most likely to induce movement of the chromatophores, while frequencies above 800 Hz did not respond at all. Based on this data, we prepared some sounds to be used in the performance. Here, I would like to consider the act of creating this music as an attunement that occurred during the production stage of this work. In order to make this performance, it was necessary to carefully examine the overlap between the sounds that tend to stimulate the chromatophores and the sounds in our audible range. In other words, the transduction of audio data into images by the chromatophores required us an attunement to the squid cells. Next, I will discuss the transduction and attunement that occurred when performing. During the performance, the movement of the chromatophores was magnified with a digital microscope and projected on a screen. The sound input to the chromatophores was played to the audience through speakers. It was necessary to change the order of sound in the parts of the squid used in the performance according to the species and individuals of the squid. Since some of the chromatophores in some squid were dead, it was necessary to determine which parts of the squid to use for the performance on the spot. In the performance, computer-generated sound data is transduced into sound waves by the speakers and into images by the chromatophore. And for this transduction to work, the artist had to attune to the state of the squid at the time of performance and change the content of the performance flexibly. Here is a summary of the transduction and attunement that occurred during the production and performance phases of this work. First, in the production phase, attunement was required to create appropriate sounds for transduction, which converts sound data into images. Then, attunement was required to adjust the volume of the sound in the position of the electrodes according to the state of the squid in order to actuate the chromatophores using the prepared sounds. Dupree discussed attunement as a kind of communication that occurs between animals and humans, but here I discussed attunement between people and animal cells. The uncertainty of the organism demands endless tuning as we attempt to control it. While the computer, the squid chromatophore, and the loudspeaker each transform signals, the human cannot help but stop tuning in order to appreciate them. Thank you.
Conclusion. This panel discussed the three historical and contemporary cases related to phonography as a sound writing technique. Three cases of reinventing phonography. Examining them from the perspective of transduction and attunement, we propose these 3 points concerning humans, non-human beings, technology, media, and art. 1. The historical example illustrated that the sound writing technique essentially required the human body, Edison's body, to act as part of the transducer process of transforming physical energy into audio information. 2. The process of creating and listening to merely had a little lamp demonstrated by Jo and Demarinis. The contemporary experiment of reinventing the phonography shows that diverse attunement between human body, human perception, and materials involved in the mechanical and engineering transactions. 3. Yokokawa's artwork, Chromatophony, shows the possibility that such attunement is not limited to human bodies and intentions, but is available to the human machine assemblage and therefore to non-human beings. Reinventing phonography is a form of media archaeology that imagines possible pasts and futures of technology outside linear media history. It offers critical insights into technologies based on anthropocentric rationality and efficiency, and reveals the aesthetic of non-human beings that go beyond the human body and species. Our contribution is a proposed theoretical framework for demonstrating non-human aesthetic functions of media art. We hope this panel will provoke a wide range of discussion. We invite you to post your comments and questions about the panel's discussion on this Twitter account. Thank you for listening.